This video is for the Logs F section of the Logarithms module. To begin, we're going to look at logs with special bases. Now these special bases are the ones that our scientific calculators can evaluate for us. And the first one is base 10, and that simply means if we see log of x without any base written, we assume it's a base 10. Okay, so if I see log of 5, that actually means log base 10 of 5. And you can see that's written just here. So if ever you see log of x, it just means log to the base 10. It's assumed that if no base is given, that it's a base 10. Base e is our natural log, and it's written as ln of x. Note that I said ln of x, not in of x. Again, there's no base specified there. In this case, the base is the irrational number e, and that's approximately 2.718. You can find that e on your calculator. So if ever you see ln of x, it actually means log e of x. Now when using the calculator for logarithm calculations, use either that log or the ln button, so make sure you can find those on your calculator. Appendix B in the textbook shows how to use your calculator for logs, so you may want to pause this video now and go and read that. Now let's use our calculator and make sure we know what to do. These questions are just saying use your calculator to evaluate and round to 3 decimal places. A lot of our logs will be irrational numbers, so you will need to approximate. So log of 10 actually means log base 10 of 10. If you plug log of 10 in your calculator, you'll get 1. So try that. Make sure you can get that answer. Log 7, again, it just means log base 10 of 7. If you plug that into your calculator, so give it a go, log of 7, you should get approximately 0.845 to 3 decimal places. Now let's try some natural logs. Ln of 3, again remembering that that means log to the base e of 3. So plug that ln of 3 into your calculator and you get approximately 1.099. Now note on your calculator it's actually 1.0986122, etc. We're going to 3 decimal places, so we look at the next number. It's greater than or equal to 5, so we have to add 1 to this 8, so it becomes 1.099. ln of 1 all squared, again remembering log to the base e of 1, that's all squared. Log to the base e of 1 is 0, and 0 squared is 0. Make sure you can use your calculator to evaluate. Now you might no doubt asking, well, not all logs are to the base 10 or the base e, so how do I evaluate those? Well, calculations of logarithms and other bases need to be changed to either a base 10 or a base e so that we can evaluate them on the calculator. And we use these rules in this box to be able to do that. So if I have log a to the x, I simply go log of 10, remembering that that is log to the base 10. So log x over log a, again they're both base 10. So this rule here is changing them to logs to the base 10. This rule here, log a of x, again instead of putting the log to the base 10, I can put natural log, so ln of x over ln of a. And then you can evaluate them on the calculator. So let's give that a go. Here I've got use your calculator to evaluate, again calculate to 3 decimal places. So log base 2 of 8. So using that rule, I'm going to just go to base 10. Okay, that's what we normally do. You normally go base 10 rather than natural log. So that would become log to the base 10 of 8 over log to the base 10 of 2. And then you go to your calculator and go log of 8 divided by log of 2. So plug that in and see what you get. You should get 3. Again, your alternative would have been ln of 8 over ln of 2. Try that on your calculator. You'll get the same answer. Okay, next one, log base 3 of 81. Pause the video, give it a go. Okay, don't just watch this, have a go yourself. Okay, so we've got log of 81 over log of 3. Again, both logs base 10. So log of 81, plug it into your calculator. log of 3, and you get the answer of 4. Again, you could have used ln of 81 over ln of 3 and you still get the same answer. Last one, log base 3 is 6, so that would become log of 6 over log of 3. Plug that into your calculator, and this one is not an exact answer, so I need an approximate sign, and it's 1.631. Alternatively, ln of 6 over ln of 3, and you get that same answer. Okay, so what now? Well, you need to go and practice. There's 2 exercises in your textbook, logs F1 and logs F2, so give them a go.